The fundamental theorem of calculus. So for the past few lessons, we've been looking at the antiderivative, and we've also been looking at the area under the curve, or the definite integral, and we've been alluding to the fact that these two things are connected. In fact, they are definitely connected. Now, we haven't formally shown how they are connected, and we're going to do that in a different video, but they're definitely connected to each other. They have some kind of relationship. So we're going to look at this relationship and show it through something called the fundamental theorem of calculus. So to start with, to understand fundamental theorem of calculus, we should think of kind of a big idea in math is that every math operation has an opposite. For example, times, divide, square, square root, exponents, logs. So in calculus, we can differentiate things, which is finding slope, and that finding slope has an opposite operation. And we can get that opposite as an antiderivative. And that antiderivative actually is to do with finding area. So we're going to look at opposite operations of calculus as differentiating, finding slope. Anti-differentiating is finding area under a curve. Okay, so the first part, the fundamental theorem of calculus has two parts. So this is part one. In that the part one just basically states that when I integrate and differentiate, they undo each other. So here I have the big F is the integral. So if I take the antiderivative and I differentiate an antiderivative, I get back to where I started. So I start with my original F function. I'm going to find the area or anti-differentiate to get big F. And when I differentiate the big F, I'm back to where I started, the f of x function. So the part one of the fundamental theorem of calculus is that integrals and derivatives are opposite operations and they essentially undo each other. So that's part one. Part two is this idea that the area under a curve, or in this case, a definite integral, this is our definite integral here, that definite integral, or the area under the curve, can be found by a displacement on the antiderivative. So if I take the displacement, the distance or the difference between f of b, the endpoint, minus f of a, the starting point, that displacement can be represented by the area under the curve and vice versa. So there's two parts to this fundamental theorem of calculus. Part one is the derivative and antiderivative, or the integral and derivative are opposite operations. Finding slope is opposite of finding area. And the second part is that we can find the area under a curve as a displacement on an antiderivative function.